Have you ever stood in awe of a massive factory, a sprawling power plant, or a colossal bridge? These are more than just structures. They are the heartbeats of our modern world, the industrial powerhouses that fuel our lives. But how did they come to be? Today, we embark on a journey to uncover the incredible engineering stories behind the creation of these industrial giants. From the first spark of the Industrial Revolution to the high-tech automated factories of today, the story of industrial engineering is a tale of human ingenuity, relentless ambition, and the quest to build bigger, better, and more efficiently. It's a story written in steel, concrete, and circuits. Let's travel back to the late 18th century. The world was on the brink of a massive transformation. The invention of the steam engine by James Watt wasn't just a new machine, it was the key that unlocked a new era. For the first time, power wasn't limited by muscle, wind, or water. This reliable, powerful source of energy made mass production possible. Think about the first textile mills in Britain. These weren't just buildings, they were complex systems. Engineers had to design structures that could withstand the constant vibration of hundreds of looms. They had to create intricate networks of belts and pulleys to distribute power from a central steam engine to each machine. It was a mechanical symphony, a marvel of coordination that laid the groundwork for every factory that followed. The engineering challenge wasn't just about the machines, but about creating an entire ecosystem for production. As industries grew, so did their needs. The demand for steel skyrocketed. This led to one of the greatest engineering leaps, the Bessemer process. Before Henry Bessemer, producing steel was a slow, expensive craft. His invention, a massive pear-shaped converter, could turn molten iron into high-quality steel in a matter of minutes. Imagine the scene, a fiery, roaring furnace tilting to pour out a river of liquid steel. The engineers who designed and operated these converters were true pioneers, taming immense heat and pressure. The Bessemer process didn't just make steel cheaper, it made towering skyscrapers, sprawling bridges, and a global network of railways possible. These steel mills became the cathedrals of the industrial age, monuments to our ability to manipulate materials on an epic scale. With factories churning out goods and steel mills forging the skeleton of modern society, another challenge arose: power. How do you supply electricity to an entire city or an entire nation? The answer lay in another engineering marvel: the hydroelectric dam. Take the Hoover Dam, for example. Built during the Great Depression, it was a project of unprecedented scale. Taming the mighty Colorado River required diverting its entire flow through massive tunnels blasted into the canyon walls. Engineers had to develop new techniques for pouring and curing concrete on a colossal scale to prevent the structure from cracking under its own immense weight. The dam itself is a masterpiece of arch-gravity design, using the power of geometry and the weight of the water to press itself firmly into the canyon walls. Inside its heart, giant turbines and generators, each a complex marvel in its own right, convert the immense force of falling water into clean electricity. The Hoover Dam didn't just light up the American Southwest, it became a symbol of what humanity could achieve when faced with a monumental challenge. Let us fast forward to the 20th century and the rise of another industrial powerhouse, the automotive assembly line. Henry Ford didn't invent the car, but he revolutionized how it was made. His vision was to create a car for the masses, and the key was efficiency. The moving assembly line was an engineering breakthrough in logistics and workflow. Engineers meticulously broke down the complex process of building a car into hundreds of simple, repeatable steps. They designed the factory layout so that the chassis would move past a series of workstations, with each worker performing a specific task. This required incredible precision in timing and parts delivery. The result was a dramatic reduction in the time it took to build a car, from over 12 hours to just 93 minutes. The Ford River Rouge complex in Michigan was the ultimate expression of this idea. Self-contained city of industry with its own steel mill, glass factory, and power plant. It was a perfectly integrated system, a machine for making machines, and it set the standard for mass production for decades. Now, in the 21st century, we are witnessing the birth of a new kind of industrial powerhouse, the Gigafactories. These aren't just large factories. They are ecosystems of innovation, designed for extreme scale and sustainability. Take Tesla's Gigafactories, for example, which are built to produce batteries and electric vehicles on a scale never seen before. The engineering behind these facilities is mind-boggling. They are designed as a single, integrated machine. The layout is optimized by physics-based simulations to minimize the distance parts have to travel. Armies of advanced robots work in perfect harmony with human technicians, performing tasks with superhuman speed and precision. Furthermore, these factories are designed to be environmentally sustainable. They are often powered by vast solar arrays on their roofs and incorporate extensive recycling systems to create a closed-loop manufacturing process. These gigafactories are more than just production sites. They are blueprints for the future of industry: smarter, faster, and cleaner. They represent the next chapter in our quest to build, from the steam-powered mills of Manchester to the robotic gigafactories of today, The creation of industrial powerhouses has always been driven by brilliant engineering. It's a story of solving impossible problems, of taming the forces of nature, and of constantly pushing the boundaries of what is possible. These marvels of steel and silicon are not just about producing goods. They are about shaping our world, enabling progress, and building the future. The next time you see a factory on the horizon, remember the incredible journey of ingenuity and determination it represents. Thank you so much for joining me on this journey through the world of industrial engineering. If you found this fascinating, please hit that like button and subscribe to the channel for more deep dives into the marvels of science and technology. We'd love to have you with us. See you in the next video.